Least squares linear approximation. So here basically we have a data set of points on the xy axis coordinate wise, and we want to fit a straight line as best we can. We can do this by eye. If we did it manually, just plotted them, sketched them by hand, the data points, and then drew the best line by eye, fitting through the points, we could then choose a point A on the line and a point B, and we could find out the gradient, couldn't we, of that line between those 2 points, and we could work out the intercept here, or we could use the line going through these 2 points and we could get the actual equation of the line. And we did that in the previous question, didn't we, fitting a line to 2 points on the line. So we've done that before, but here this is the method of least squares. So given that data set, we want the best fit, don't we, at all possible, and this is one proposed method for finding the best fit straight line through a data set, a series of coordinate points. So we label them, the first one x1, y1, here it is here, then x2, y2, suppose it's here, then x3, y3, there, and all the way up to xn, yn. So the x's are arranged along here, the y's up along here on the y corresponding values. We calculate the deviations from the points to the line. So we suppose that there's a line, y equals mx plus c, and then we work out d1 would be y minus m1x plus. Input the x1 and you get the value on the line. So that d1 would be the difference between the y coordinate y1 and the value on the line at x1, input x1, mx1 plus c. So that distance there is d1. This is d2 all the way up to, and there's d3 all the way up to dn. So you write all those down, and the least squares method is, the formula is here. So select them and see so that the sum of the squares, so you look at this when it's a minimum. When is the sum of all these square distances a minimum? So add this squared, add this squared, add this squared, and this squared. And when you add them all up, you want to find out when that distance total value is a minimum. So the di, as we said before, was this value for each I. I goes from 1 to n, so this means sum. So sum all the, it's just a shorthand notation, sum all the di squareds from 1 to n, so it's d1 squared, d2 squared, d3 squared, all the way up to dn squareds. Here's the value of the respective di's, isn't it? Here. So put that in. There should be another bracket there because it's y minus this value, bracket squared. When is that a minimum? And in this case, this is all we do. It's a simple calculation. We work out m from this formula. This is the sum of all the products of the coordinates, xi, yi's, minus n x bar, y bar, and over the sum of the xi squareds minus n, which is the number of data points, times the x bar squared. And then our c value is y bar minus mx bar. The x bar and y bar that's mentioned in the formula is just the average of the x values, so sum of the xi's over n, and the y bar is the sum of the y's, the average of the y value, sum y's over n. So with that thought in mind, and here's our formula, we'll look at this problem. Okay, so I'm just going to move this up the top of the board to give us some working room here. We'll work out these formula as far as I can go. Okay, that will do. So there's the formulas then. We need to work out m and c. Find the least squares to the straight line, this. So we're going to need the xi's. Here's the xi's and the yi's. Let's do a table. So here's the xi's. 0.5, 1.3, 2.5 and 3.8. Here's the yi's. 1.8, 4.1, 4.6 and 7.9. And then we need, what do we need in our formulas? Well, we need the xi, yi sum, don't we? So let's work out the products and add them all. And then we need the xi squareds, don't we, as well? That's mentioned here, isn't it? So the xi squareds, and that's all we need, I think. So let's work those out on the calculator then. And what we'll do is we need the sums of all these, don't we? So this one would be the sum of the xi's. this number here. This will be the sum of the yi's. This will be the sum of the xi yi's. And under here will be the sum of the xi squareds. Okay, add this 2.1, 0.5, 1.8, 3.8, 4.3, 4.3, 7.3, 8.1 I reckon. We'll check it in the calculator if we need to. So let's put this over here. We'll do the calculations. So I'll just run through it quickly so that we're absolutely sure. Yeah, 8.1. Next one. Plus 4.1 plus 4.6 plus 7.9. That's the sum of the yi's. 18.4. Okay. And then some of the xi yi's. Well, we'll have to add them up. But we only need the sum, so I'm just going to work out the sum. Although you could do the table, this would be 0.9. And then you get these as well. So let's try them, shall we? 1.3 times 4.1. What do we get? 5.33. 2.5 times 4.6. 11.5. And 3.8 times 7.9. The good thing is you get method marks if you do a table like this, even if you get the end result wrong. 30.02. Okay, let's add them up. So you've got 0.9 plus 5.33 plus 11.5 plus 30.02 is 47.75. Now the sum of the xi squares, that's 0.25. That's 1.69. That's 6.25. And 3.8 squared is, I don't know that one. That's 14.44. So add that to plus, so the 14.44 plus 6.25 plus 1.69 plus 0.25, which is 22.63. Okay, that's all the ammunition we need then. Let's get our formula. So let's worry about M first, I think. Although we need X bar and Y bar, don't we? So let's just drag that down. Now let's copy it. I think that's best. Edit, copy. Then edit, paste. Now we can move down a copy of it and we'll work with that. Put the values in. So M first then. So it's a summation 47.75 goes in here. 47.75 minus N. Well, there's 1, 2, 3, 4 data points, so N is 4. So I'll put that in there and there. X bar we need, which is 8.1 over 4. Because there's 4 data points. 8.1 over 4. .025. So that's X bar, and Y bar is 18.4. 18.4 divided by 4. 4.6. Okay, that's Y bar. Okay, so we can replace that then. X bar, Y bar. 2.025, that's X bar. Y bar is 4.6. Summation of the xi squares is 22.63. Let's put that in there. minus 4 times x bar squared, which is 2.025 squared. Squared. So there's m. So let's work that out then. Okay, so we got on the top, we got 47.75 minus 4 times 2.025 times 4.6 close bracket divided by bracket underneath 22.63 minus 4 times 2.025 squared. Close the bracket underneath equals 1.684 to 3dp. So that's good enough, I hope. 684, and that was to 3 decimal places. Okay, that's m. Now we want c. So let's go and get c. C is equal to y bar minus mx bar. C is equal to y bar minus mx bar from the formula. Just show you again. Here it is here. So we've got y bar 4.6 minus 1.684 times x bar, which was 2.025, which equals, so that's in the answer, isn't it? The 1.684 accurately, so it's 4.6 minus that times the x bar, which was 2.025. 1.188, 189, 1.189. Now it's to 3 decimal places. Okay, so the best fit then is y equals mx 1.684 x plus c plus 1.189. That's the equation of the line there. We've got another example in the notes, so I'll just copy that down now and we'll do that one. Here's the next example then. I've completed the table, the xi, yi coordinates, the products, you can check all those are correct, and then the summation of the xi squareds, all there. And I've totaled them all up. These are the 4 things we need. And we also need x bar and y bar. X bar is the average, so 7.54 over 1, 2, 3, 4, 5, which is 1.48. And this one is 0.282 when you tap it in the calculator, x bar and y bar. So m, summation of x, I, y, 2.255 then. Let's put that in. 2.255 minus n, which is 5 now, x bar, y bar, minus 5 times x bar times y bar over the summation of the xi squareds, which is 13.26. 13.26 minus n, which is 5 x bar squared. So minus 5 is n times x bar squared, 1.48 squared. So there's m. So let's tap it in the calculator then. Top number 2.255 minus 5 times 1.48 times 0.282, close the top bracket, divided by the bottom bracket, 13.26 minus 5 times 1.48 squared. Close the bottom bracket, equals 0.0728, 0.073, 0.73, and that's the 3 decimal places. Now we've got m accurately in the calculator, so we can do 0.282 y bar minus m 0.073 times x bar, which is 1.48. Okay, so that's the answer there. So it's 0.282 minus the answer times x bar